area bounded by polar curves. And this is 10.4. We'll talk about the length as well. Let's take a step back and look at the following. The area of a triangle, like so, if this is the base and this is the height, I'm taking you back to the time where the wheel was invented, sort of. It will be 1/2 the base times the height. Okay? In trig, we saw that area of a sector, part of a circle, if you have a circle, actually in Calc 1, and you had a circle, let's say a sector that goes like this, okay, the arc length was d theta, the radius was r, and the area of the sector was 1/2 r squared d theta. I'm sorry, the length of the sector, the arc was r theta. Oh, I'm sorry, I'm making a mess here. So let me retract what I just said, or what I wrote at least. I think I said it correctly.
Did they tell you to go slow?
Told me to go slow, right? All right, here we go. The arc length is r theta, the arc of this piece of the circumference. And if you multiply, if you integrate, then you end up having 1/2 r squared theta. Okay, this is what they taught you actually in trig. I was right the first time. From calculus standpoint, what we do when we have a curve, a curve, let's say this curve, and we take a very small piece right there, right? How small? Well, we say it's infinitely small piece of arc length. So small, we call it r d theta. In other words, the angle that span this arc length is infinitely small, approaching in 0, so we call it d theta, and it's so small that it doesn't matter. There is no difference between one side of the angle or the other side of the angle or r. And therefore, we're going to say that an infinitely small element of the area, that sliver that created by this sector, and this is a regular curve. It's not necessarily part of a circle. Of course, it applies also to a circle. Then that area will be 1/2. I'm sorry, it will be r. Well, I approach it as a triangle, so it will be 1/2 r times r d theta, or 1/2 r squared d theta. And of course, if you have a larger area, so now if you have a curve like so, and you want to know the area captured, and let's say this point is theta equals theta 1, and this point will be theta equals theta 2. Of course, the point will be r theta 1 and r theta 2. I'm just relaying to the boundaries of theta. Well, the area of this sector will be the integral from theta 1 to theta 2 of 1/2 r squared d theta, and this will be, and that's it actually. This is the formula, the area formula. This is overly simplified. It's not a proof. It's just, I think I put it upside down. There you go. This will be just, as I said, it's just the result. This is rather a qualitative explanation than a rigor mathematical proof of the area formula. But for the time being, it's sufficient. So let's look at the first example here. And we are looking at, we go back to the four leaf rows, and we want to find the area of one leaf. Find the area of one leaf, or area enclosed by. One leaf of the four leaf rows. Remember, the four leaf rows was R equal cosine 2 theta. Before we jump into the solution, let's draw our rows one more time. It's a good practice. So let's say I want to calculate this area in particular. Why do I want to do it? Because I know that this point corresponds to theta equals 0, and also we discussed the value of theta at the pole, right there. We said it's pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. What values will take in particular if I'm looking at as I travel like so? Remember the direction. So I go from 0 to pi over 4, and on my way back here, I'm going from 7 pi over 4 to 0, right? So this section right here will be theta is greater than 0 and less than pi over 4. And this section right here, theta is greater than 7 pi over 4 less than 2 pi. I'm going to replace that by theta is greater than negative pi over 4 but less than 0, which is the same thing. The reason I do that is because I want to calculate the area instead of going from 0 to pi over 4, jump and go from 7 pi over 4 to 2 pi. I can go from negative pi over 4 to positive pi over 4 and do it one time. Okay? The other reason is the symmetry. If I'm going 0 to pi over 4, get the top half, actually, all I had to do is go 0 to pi over 4 multiplied by 2. That's another way to do it as well. Get only the top half. Well, actually, let me see. This applies to Cartesian, not polar. So I need to check. I need to think a little bit if to go from 0 to pi over 4 would be sufficient. But it's definitely sufficient to go from negative pi over 4 to positive pi over 4. In other words, I'm going in reverse. I'm doing this, not in reverse actually. I'm starting here and I'm going like that. So I'm in the direction of the curve. If you go in reverse, you get the negative result. Okay, so instead of starting here, I'm starting here. Notice the direction of the curve. It's still in the right direction. So you go from here to here and then come back. And that's what I'm doing. The rest is very simple. R equal a cosine of 2 theta. So when I square it, I get cosine of 2 theta squared, d theta. And remember, here we have, well, let's pull the 1/2 outside the integral. And remember, what is the square? Square, we use double angle identity, and we get 1/2, 1 plus cosine of twice of what we had before. But since we had before 2 theta, now it will be 2 cosine 4 theta. D theta. Okay? Can you see that it's 1 plus 2 cosine 4 theta? Good. This is double angle identity. So continue. Now we have 1/4, right? And we need to integrate 1 in 2 cosine 4 theta. Well, we have theta for 1, and here the integral of cosine 4 theta is 1/4 sine of 4 theta. So we have 1 plus 1/2, 2 over 4, 2 times 1/4 sine of 4 theta. I'll do it like so. Evaluate from negative pi over 4 to positive pi over 4. Here's the thing. If you think about sine of 4 theta, if you have pi over 4, then you have either sine theta or sine pi or sine of negative pi. In any event, it's 0. Okay? So the only value that we're going to include is theta. So we end up having 1/4 times pi over 4 minus negative pi over 4. So this will be pi over 2, and times 1/4, we end up having pi over 8. Pi over 8 is one leaf, and if you want to find the area of all fours, of course, it will be pi over 2. If you think about it, if you want to find the whole area, if you go from 0 to 2 pi, okay, this is the antiderivative right here. If you go from 0 to 2 pi, again, you have the sign will go to 0. And you end up having 1/4 times 2 pi. Well, it will be pi over 2. 1/4 times 2 pi will give you the same thing. Okay?